Sorry about the glitch in the last part of the clarifications module. There was a minor crash in my software. So, let us proceed with this again. Suppose you had a function of two variables f of x y and you want to worry about whether a given point x naught y naught is a minimum or maximum. You will expand it up to second order and Taylor expanded up to second order. The first derivatives are 0 because the stationary points are found by partial x partial f partial x 0, partial f partial y 0, and the points that you get are denoted as x naught y naught. These are called stationary points. What are the nature of the stationary points? Are they maximum or minimum? You have to expand it to the next order. Then we rewrote this as f x x times delta x plus f x y delta y by f x x whole squared plus delta y squared f y y minus f x y squared by f x x. Right? Now, the question that was raised by a student was, what if this is identically 0? What are the conditions? Now, first thing that you should understand is that the conditions anyway are you have to have for a maximum, for a minimum this has to be greater than 0, and for a maximum both have to be less than 0, right. That is something that is bare minimum, that is the that is the least thing that you should expect in order for these stationary points to be maximum or minimum, because if you walk along only one of the coordinate directions, then obviously you must satisfy these conditions. Now, in addition, if this was to be 0, then this term is not going to matter. So, the only term that is going to matter is this, right. In the special case where this is identically 0, you do not have to worry. You still have this condition, whether f x x is greater than or 0 or less than 0, you can still worry about, you can still judge whether the function is maximum or minimum. Now, one last question that was raised was what are the applications of this finding the maxima or minima of functions of two variables. The applications are abound in thermodynamics. Chemical engineering thermodynamics is all about if you have a function, Gibbs free energy is a function of temperature and pressure, entropy is a function of internal energy and volume, or you have internal energy as a function of entropy and volume. There are various criteria for finding equilibrium as per second law of thermodynamics, which says that entropy is a maximum and Gibbs free energy is a minimum and so on. So, if you have a thermodynamic model which gives rise to an expression for G of Tp, then you have to figure out, in order to find the correct temperature and pressure at which the system is at a minimum, then you have to find the second derivative and then judge whether you first have to find the first derivatives and locate the stationary points and then look at the second derivatives and so on. So, these expressions that we derived in the previous module are absolutely essential. Okay. So, I will stop this module here and I will continue with a new module on complex numbers and complex analysis. Thank you.